When we want to show the relationship between two variables, we would use a scatter plot. On Excel, the way we draw a scatter plot is we take the data set up in two columns. Whatever is in the first column is going to show on the horizontal or x-axis, and then whatever's in the second column will show up on the vertical or y-axis. To begin, you select the data in both of the columns, then you go up here and you click on Insert, go to the Charts section. Scatter plot is going to be this icon right here. If you hover over it, it should say Insert Scatter or Bubble Chart. Then you're going to select the very first option right here. Click on that. And at this point, we have to add a few things. We have to add labels for the axes, a best fit line, and then some information, mathematical information about the best fit line. To insert the axes labels, we're going to go to the chart design, making sure that that's clicked. And we're going to add a chart element, axis titles, horizontal, same thing, but now vertical. And then we're going to add a trend line. And in this course, the only trend line that we'll be using is the linear one. So when you select a trend line, it's always going to be linear. Finally, we want to show mathematical information about this trend line. So we're going to click on this one more time, go back down to trend line, and then click on more trend line options. You can see that a window popped out over on the right here. What we need to do is check two items. We want to check display equation on chart, and we want to check display R-squared value on chart. At this point, we just need to fill in our labels and then see if there's any formatting that we need to fix. The way that you title a scatter plot is the whatever's on the y-axis, which is number of dead fish, as a function of whatever's on the x-axis, dissolved oxygen. So number of dead fish as a function of dissolved oxygen. On the x-axis, we have dissolved oxygen. When you label an axis, it's important to put in the measurement as well as the unit. Dissolved oxygen is measured in terms of parts per million, so it's very important to include that. For number of dead fish, there isn't really a unit for it because it's just that the number is, in fact, the unit. So number of dead fish. Okay, now what we have here is this box. I like to move it up to the top right here, just so it's front and center. This box shows two pieces of information. It shows the equation of the line in the form of y equals mx plus b. So y equals, and then this number right here, 3.3295, is the slope of the line. The fact that the line is going down is reflected in the fact that the number has a negative sign in front of it. Then we have x, and then plus 27.316. This is where the line hits the y-axis, otherwise known as the y-intercept. This value right here, r squared, shows us how well these points are fitting a straight line. The number is measured between 0 and 1, where 0 means absolutely no straight line trend is shown. If the number, as the number gets closer to 1, it means that the data are forming a straight line more and more perfectly to a straight line. So the fact that this is 0.9, higher than 0.9, means that these data, we would say, have a fairly strong correlation. Usually with your experimental data, you can end up with R-squared values of 0.98 or even higher.